is about graphing rational functions and using what we call RADI style. And RADI is an acronym for all the things that we've been doing, so here we go. Okay, so graphing a rational using RADI. All right, before you use RADI, you first must factor the numerator and the denominator, remove any common factors. Because remember, common factors tell you where the holes are located. So you take the holes out, and then you jump into RADI. Well, what is RADI? Well, RADI, R stands for the root. Set the numerator equals 0 and solve it. A stands for asymptotes. This is just vertical asymptotes. Remember, you set the denominator equal to 0, solve it for x, then we graph it. And then we look at the factors in the numerator and the denominator, okay? If it's in the top, the numerator, if you have even numbered exponents in the top for those factors, like a factor's repeated in the top, that's tangency. If a factor's repeated in the top, that's what you call tangency, like an x plus 2. If it's squared, then that's tangency at that root. Remember, that's a root. If it's in the bottom, it's not tangency, it's what we call togetherness, okay? So it's togetherness about an asymptote because that comes from the bottom of the equation. We've talked about this. E is for end behavior asymptotes. Bobbio, Botno, eats DC, okay? One of those three is what we call the end behavior asymptotes. Remember, if it's Bobbio or eats DC, you want to see does it cross the asymptote. And we talked about how to do that previously as well. Lastly, y is for the y-intercept. Remember, plug 0 in for all the x's and solve it for y. We've been through all these steps. RADI just puts it all together in one acronym, so you remember all your steps. Okay, so let's try this. Okay, here's my equation. X minus 1 over x squared minus 4. First thing I want to do is factor. Always factor if you can. Bottom is a difference of squares, so x minus 2 times x plus 2. Alright, so I have it in factored form. Let's look. Are there any holes? Do I have any factors in common? No. Okay, what are the roots? Well, you set the top equal to 0 and solve it for x. Well, that makes x equal to 1. So it's a point, 0, 1, or 1, 0, sorry. A is for asymptotes. So you set each factor in the bottom equal to 0. So x minus 2 equals 0, x plus 2 equals 0. So this one is x equals 2. This is x is negative 2. So I have two vertical asymptotes. Tangency at the roots. Okay, so I look in the numerator. Do I have any factors repeated in the numerator? No. So nothing's bouncing off the x-axis. Togetherness about the asymptotes. I look in the denominator. Do I have any factors repeated in the denominator? No. This is x minus 2. This is x plus 2. They're different. They're not the same. So there is no togetherness. End behavior, okay? Is this a Bobbio, Botno, or eats DC? Exponent power is 1 on top, it's 2 on the bottom, so this is bigger on bottom. So this is Bobbio. Remember, if it's Bobbio, yo is yo answer. Oops. So it's y equals 0. Now, I have to stop and think, does this cross my asymptote? Well, if y equals 0, I set my equation equal to 0 and solve it. Okay, if I cross multiply, x squared minus 4 times 0 is 0. So I get x minus 1 equals 0. So x is 1. So it is going to cross where the x is 1 and the y is 0. And if you remember, that's the same place as my root. Sometimes that happens. Y-intercept, remember you take every x value in the equation and put in a 0. So I have negative 1 on top. 0 minus 2 is a negative 2 times 0 plus 2, which is a positive 2. So I have a negative 1 over negative 4, which is positive 1/4. So my y-intercept is at 0, 1/4. All right, now we can graph this. I have a root at 1. I have a vertical asymptote at negative 2. And I have one at positive 2. Right? No tangency, no togetherness. End behavior is at y equals 0. And yes, it's going to go through that root, but we already knew that was going to happen. Y-intercept is at 0, 1/4. All right. So it's less than 1, but it's right there. Now remember, if you have a middle section between two asymptotes, it's either going to be a parabola or cubic? Well, how do you know? Well, if it crosses the x-axis, it's going to be a cubic. And notice, these two have to connect, so that means it's going to be cubic, and it's going to go this way. There's only one place it crosses. Now, I know enough about togetherness, we've talked about togetherness, that there is no togetherness in this graph. Once I figured out the middle, I look over here in the left section. I know it's not together, so if the curve is going towards the top, if it's not together, that means the curve in this section has to be going down. On the right section, it's not together with the middle, so if the middle's going down, then the curve over here has to go the opposite direction, so it's going up. And that's all I have to do. If you're not comfortable with that, you can always do an XY table and pick an X coordinate over here, pick an X coordinate over here, and find those Y's. But your togetherness clues from your equation will tell you where the curves are going. Let's try another one, x over x plus 2. All right, it's already factored for me. Thank you very much. Now, are there any holes? No, no common factors that will cancel. The root, if x is just x on top, it's just x equals 0. So my root is at 0, 0. Vertical asymptote, I said x plus 2 equals 0 and solve it. So x is negative 2. Tangency at the roots, are any factors in the numerator repeated? No. Are any factors in the denominator repeated? No. End behavior, Bobbio, Botno, or eats DC. Okay, look at the exponent. Exponent on top is 1, exponent on the bottom is 1. Well, its exponents are the same, so that's an eats DC. If I divide coefficients, 1 divided by 1 is 1, so it's y equals 1. Now I need to stop and decide, does it cross? Well, work it out. X over x plus 2, set it equal to my end behavior, which is a 1. Cross multiply, I get x plus 2 equals x. But if I have an x on both sides, they cancel out, and I have a 2 equals 0, but that's not true, so we know it does not cross. Y-intercept, put in 0. So I have 0 over 0 plus 2. Well, anytime 0 is on the top, that is just 0. Alrighty, so my root and my y-intercept are the same. Alright, vertical asymptote at negative 2. Okay, end behavior is that y is 1. And I know it's not going to cross the end behavior, but I know it has to go through this intercept right here, so it's going to curve this way. Can't cross the vertical. Now over here on the left-hand side of my picture, what do I know about togetherness? I know it is not together, so if the curve is going down on the right, that means it has to go up on the left. Alrighty? Alright, so before you jump to number 4, I want you to go down the bottom of your notes where I have different kinds of questions. Alright, we've talked about this a little bit, but I want you to be comfortable with this type of question, so we're going to practice some more. So look, it says to write an equation with roots at negative 4, 0 and negative 1, 0. So we know that to find roots in irrational equations, that comes from our numerator, and we have to solve the factors in the numerator to get our roots, right? So what I need to do is write a factor that would solve to give me -4. So if you remember, to write the factor, you're just switching the sign. So if this is -4, this becomes a +4 in factor form. And the -1 would become +1 in factor form. But remember, factor form has x plus something, x minus something. That's factor form. Now, that would give me the appropriate roots for this one. Now, to be rational, something has to be on the bottom. Doesn't matter as long as these are the two roots, since that's what the question is asking. So I could just put something simple like x minus 2. It doesn't matter. When you get a question like this, leave your answer in factored form. Don't put it in standard form. Leave it like this. Because I'll be checking. If like this one is roots, I'll be checking to see that you have these two factors there. Okay? Look at number 2. Write an equation with a vertical asymptote of 3 and -2. Now remember, vertical asymptotes come from factors in the denominator. All right, so I've got to write an equation that has a numerator and denominator, and the factors in the denominator solve to be +3 and -2. So just like before when we created factors, we're just switching the sign. So to get +3, I need x minus 3. To get -2, I need x plus 2. Now this question only asks me for a specific vertical asymptote, so I can put it whatever I want in the numerator. I could just put a 3. It doesn't matter. These factors are what I would be looking for. Number 3, write an equation with a horizontal asymptote of y equals -3. Now, remember when we do horizontals, right now all we do are Bobbio's and Eats DC's. So we got to think, okay, which situation is this? Well, if it's a Bobbio, if the power of x is bigger on bottom than the y equals 0, we want y equals -3. So I know Bobbio is not what it is. So this has to be a situation that it's Eats DC. So the exponents have to be the same, whatever it is. Whatever it is, the exponents have to be the same. So I'm just going to put an x on top and an x on bottom because they have the same exponent. The DC means divide the coefficient. What I know is that when I divide the coefficients, I need to come up with a -3. So I could do -3 over 1, or you could do 3 over -1, or you could do -6 over 2. Doesn't matter as long as the coefficients divide to be a -3. Any of those three are possible answers. So with these types of questions, there's lots of possible answers, but there's key things that I'm looking for. Make sure you read carefully to answer the appropriate question, and then box in your final answer. Okay? Box that answer too. All right, there you go. Now, I want you to try number 4 on your own. Okay? I'm not going to work it out on the video, but we're going to work it out in class. But I want you to go as far as you can, possibly finishing it before you get to class. All right? Good luck and see you then.